Hi, my name is Michael Chikeen. The smartest people I've met have one common belief that us silly humans really don't know much. For example, we still don't know why planes stay in the air, or how Tylenol or even gravity works. Yeah, gravity. Look it up. In today's distracted, clickbait, misinformation age, I wish we could all be less certain, more humble, and a lot more curious. Admittedly, I've been known to struggle with all three. So, no more, no less, this show is my attempt to be that change. Thanks for joining me, and here we go. Hi, everybody. Welcome back again to No More, No Less. I'm your host, Michael Chikeen, and today in the studio, I'm excited to have with me Richard Anderson. Today, we're going to talk about, that everyday practical process of space colonies for human habitation. Richard Anderson is an alumnus of San Jose State University. He has a master's degree in microbiology. And before the pandemic, Richard spent a lot of his time researching what fascinated him during his university years. And from that research, he discovered new, exciting information that became the subject matter for his recent book titled The Evolution of Life from Big Bang to Space Colonies. So now I'm looking forward to learning how us humans can successfully destroy the rest of the universe. Richard Anderson, welcome to the show.
Thank you.
I wanted to start, I guess, with that little joke there that, is a permanent presence in space, could it help kind of not de-destruct, but correct the destructive practices that we've done on Earth? Because that seems to be everyone's escape thought. When we get worried about what's happening with our planet, everyone says, well, we'll just go to space. And so I'm wondering if that would help the planet as well.
I believe so in some ways, and I can explain that. But the whole thrust of my first book, which is nonfiction, was to show how intimately we're tied to the rest of the universe, and how we evolved on this planet, how we're stuck with the features of this planet because we go back to the beginning of life. We carry that genetic code all the way to the present and into the future. So in many ways, we are part of Earth. Gravity has affected us. Definitely the magnetic field of Earth has allowed us a long evolutionary period of billions of years, not possible on other planets. And we have been successful in many ways and actually self-evolved because we domesticated ourselves by the introduction of agriculture and the introduction of fire and cooking. And the control of fire also led us to technology that allowed us to control our environment to larger and larger extents. So from that sense, we are bound to Earth. We require an Earth gravity. We require a lot of features emotionally, psychologically, and physiologically. We require a planet or a place like Earth. So we have succeeded in destroying and are proceeding to destroy large parts of the planet, of our natural habitat, of the ecosystems. We're in an age now called a lot of people call it the Anthropocene, which is man-caused extinctions, human-caused. I should say women probably participate. But so then I thought, well, how can we, as the world populations, we're in a tug of war. We have progressives on one side who recognize the danger and the damage, and we have conservatives who are looking back to a theoretical past and wanting to maintain that or return to it, pulling the other way. So it's a tug of war, and we're not acting quickly enough to rescue the planet, in my opinion, and a lot of other people's opinion as well. So how do we correct ourselves? How do we get out of that? And I'll use the analogy of the Apollo program, NASA's moon program. They had the greatest collection of engineers and scientists and mathematicians and so forth the world has ever known in peacetime and directed for peaceful development. And it is exemplified in Apollo 13 mission, where they saved the astronauts through their diligence, through their collective good work and cooperation. This huge team managed to bring. They solved one problem at a time, managed to bring the team back, the astronauts back to Earth. So I thought the way that we still incredibly have climate deniers and people working against actions to reduce pollution and so forth, poisoning of soil, and our agricultural system is largely to blame for a lot of pollution, a lot of soil destruction, what's called desertification, which soil is living, dirt is lifeless, for definition. So the process of desertification takes soil to dirt and a dead entity. So to have a presence in space, we would have to replicate a lot of the Earth conditions. So we would have to create one gravity. So my thesis is we really cannot have a long-term presence on the moon as a permanent population or on Mars. We can rotate populations there, but I really believe that if we want to maintain our Earth-bound evolution, if we want to retain our robustness, we cannot go generation after generation in lesser gravities than we evolved on. We'll diminish ourselves. So I don't think people will find that desirable. So space colonies would have to be based on something like Dr. O'Neill's cylinder colonies that rotated, and on the inner surface by the rotation created one gravity. And within that, now it's not a Star Trek thing where you don't have an ecosystem in the Starship Enterprise. You have a holodeck, which is fake. So that's not going to work. You have to have Earth-like environments. They have to be sustained by living matter. You have to create an atmosphere and an ecosystem that will support, offer ecology. And so to do that, you would assemble a team of, initially it would be the engineers that would design the structures and the rocket scientists and all of this. And then it would become the biologists, ecologists, environmentalists, followed by sociologists, psychologists, all the humanities, the skills. And you would have to select people who were highly trained, qualified to solve problems and develop these environments off planet. So you would not, for example, you would not have any kind of pollution. You would not have any kind of, pesticides. You would not even be allowed to cook in your own kitchen. It would have to be tightly controlled so that any smoke or gases from cooking would be captured and not released into the limited atmosphere within these colonies. So you develop a team that has a broad cooperative ability and share their sciences to develop this complex system. Once that is done, it can become sustainable from space. It would have to. The Earth cannot support that. Earth launch systems are not going to put a lot of material into space. But NASA did a study early on, I believe it was in the 60s or 70s, where they wanted to determine what was out there that could be used in the future for space colonies or space development. And the asteroid belt is what they studied, and they determined that there was enough material in the asteroid belt, which lies between Mars orbit and Jupiter's orbit, right before the frost line. There's a frost line that beyond which all water is frozen. So they determined it was like thousands, tens of thousands, I don't remember the number, of Earth's side, of livable area could be created from those materials.
Hmm.
So once you had a presence in space, you had manufacturing capabilities, and you had robotic vehicles that could bring asteroids or parts of asteroids into a construction zone. And I have that in a Lagrange L5 position, which is a balanced orbit, Earth-Moon orbit. And that's where I'm focusing my initial colony.
And have they found any planets yet that are close enough that we at some point would be able to visit them? So there's an atmosphere that might be more hospitable to humans. Is there anything that's even remotely close?
Not yet. And in my book, I outline why I think that might not exist in our reachable by humans. If it does exist, it's very unlikely, so it might be somewhere far in the universe. And the reason is it gets into the density of the Earth, and the Earth's density is higher than Mercury. So Mercury, as you get closer to the sun, when the material accreted around the swirling mass of gases and materials that form the sun, the heavier elements went toward the center. It's called gravitational striation. So it separates materials by their mass. So the lighter materials are on the outer reaches of our solar system, and the heavier materials, heavier elements, are concentrated more toward the sun. So Mercury is the second most dense planet in the solar system. Venus is the next behind Mercury, the third most dense planet. The Earth is the most dense planet. The Moon is, if you want to consider that part of the inner planets, the Moon is the least dense, and Mars is right behind Earth, or right behind Venus in density, lower.
So what is it that makes one planet denser than the other, and is there a reason why a denser planet is more hospitable?
So here's the story about that. Some mathematicians put together some software, and they wanted to analyze the present position of the Moon, its speed, rotation, how it's moving away from Earth gradually each year, each rotation, because it's rotating, or it's traveling around the Earth in the same direction that the Earth is rotating. In that case, it's going to throw out to a larger orbit. If it were going counter to the Earth's rotation, it would eventually collide with the Earth. So that's just how centripetal force works. So what was happening was they developed this mathematical model, and they put the Earth and Moon in their present positions, and they ran it backwards. And what they determined was, with a high, we can't go back and look at this, but what they determined was the only way that the Moon could come into existence, it couldn't be captured from something coming in from further out in the solar system, because of the size and mass of the Moon and the gravitational field of the Earth. It wouldn't be enough to set up that orbit. The gravity wouldn't be strong enough between the two. The speed would be too great, and a bunch of factors. So what they decided was there was a Mars-sized planet in the orbital path of Earth, and it was probably at one of these balance points, like L5 or L4, and that's where the centripetal force of the orbit and the gravitational pull of the sun and the Earth all balance. So it's kind of a balance point. that it was tipped off of that balance point by either a Jupiter or Venus on a close approach or something, and it collided with Earth. So originally that planet, so they named the planet Thea, Thea. And originally that planet would have had the same density as Earth as it accreted from the same material. When it collided with Earth, both bodies became molten. It spun around and spun off a large body of material that then collided with Earth again. It did this several times, and finally we ended up with our moon. In the process of doing that, it left the more massive or the more heavy elements on Earth, and the moon became much less dense. And it's less dense than any of the inner planets. But it left all of that heavy and radioactive elements in the core of Earth. So Earth's core is nickel, iron, a lot of radioactive elements that continue to create energy and heat and plate tectonics, continue to be a dynamo that creates our magnetic field, which protects us from radiation from space and a lot of other things. So it also stabilized the Earth. It created a 13.2 degree tilt on Earth's rotation, that tilt out of the plane of the planetary plane.
Excuse
which
me.
created
I've never heard this. Sorry to interrupt. Because I've never heard of the this theory of theta. Like, is this pretty like solid evidence that there were these two planets that collided to give us all of these minerals that made Earth what it is?
Well, it's not commonly known. I'll agree. It's something I discovered in my research, but let me put it this way. When science can measure a process, they set up controls, they measure it and so forth, determine whether it's, they come to conclusions. When they cannot measure the actual event happening, they have to look at the evidence. And then they have to come up and say, what would explain what we're seeing right now? And sometimes they may have 3 or 4 or multiple theories that might come to the present conclusion or the present state of things. In this case, the only thing that can explain the situation with the Earth and Moon and the varying densities, the 13.2 degree tilt on Earth, it has a slight wobble, which is a residual from the collision. The only thing that can explain the existence of the moon as it is and the Earth as it is the collision. And they've calculated back what would be the mass of the body, what would have to be the size of the body that would cause this. And they calculated the size to be something close to Mars. So is there evidence? Yeah, that's the evidence. Is there proof? That's a pretty strong word. There are a lot of things in science there is no proof or there's no 100% understanding. So
right, because that's really interesting. Because I like the idea of like trying to, it's like how scientists are identifying black matter or antimatter, because it's not like they can see it, but they're measuring all the things around it and saying like, well, there has to be something here to account for this mass that is unidentifiable. So I wonder, because you're right, it seems like we do have a lot of minerals and resources on this planet that do not seem to be analogous to other planets, and so that would mean, well, why are we so special, so to speak, right? And and a lot of people will say, well, maybe Jesus gave it to us, but I like the idea of trying to form like this concept of like a collision at some point, because I would imagine some people would ask, like, if there was a collision, wouldn't there be like this giant hole or something in Earth? And I wonder if you've ever thought of, because I've heard on other planets that it seems like perhaps underground, under like the crust of these other planets, there's an abundance of water. And so I wonder if Earth was collided with, maybe it released this water, and that's why there is so much water that is abundant. That essentially is the circumference of the Earth. Is there any people trying to think about that, or?
The water, so presumably, as the Earth was forming, and there were a lot of collisions, there was a lot of debris in the inner solar system, including comets containing a lot of water. So they feel like there were oceans on Earth before the collision. The collision causes both bodies to melt, to become molten, and the oceans evaporate off. So as the Earth cools, that water recondenses and comes back to the planet. They believe that most of the water was from comets. Some of it could have been from asteroids. Some of the asteroids contain a lot of water in the form of ice. And so it's not that the collision itself would have boiled any water off. And because the mass was molten and was highly spinning very quickly, and as it spun the moon mass off, the spin of the Earth slowed a bit. But the early days after the collision and after the Earth cooled, we had 19-hour days. We had a moon that was extremely close, caused huge tides, and this plays into another part of our evolution in that these huge tides created large intertidal zones, which facilitated life moving from the seas to the land, which is quite a feat when you really analyze it. So the intertidal zones meant that these areas were intermittently wet, and so that it created a gradient for more tolerant life forms could survive, and then evolution finally came out with complex plants, and which entered the land first. First were lichens, which aren't really plants, but so the moon had that kind of effect too, in that it facilitated, I believe, movement of life to land. So this would get into another area called technologically intelligent beings. So scientists believe that there are many instances in the universe where life could form, and they would really love to find it. They want to know, is the genetic code the same? How similar is it? Pretty much the consensus says life can only exist where liquid water exists, which implies an energy source, which is another requirement. Carbon is the only element that can support complex molecules that would also be required for any kind of a living entity. So that's where you come up with the idea of carbon-based life. And I do go through all of that in my book. So actually, the book I'm writing right now is science fiction, and it's called it's going to the publisher very soon. It's called Islands in the Void, and it's about, okay, we have space colonies, we have this stuff, we have it's the middle of the 23rd century, okay, and 2245. I think that's a start date. And so we have all these issues on Earth in this scenario, where there's been extinctions, there's been famine, many people have died, the climate has wreaked havoc, especially around tropical and subtropical and even temperate areas of the Earth. And populations have migrated toward the poles, and the whole scenario. Okay, so there's a lot of political stuff going on, a lot of disruption on the planet. And the space island program has started, and they're initially under Earth control. But very soon, because Earth has so many problems, they can't support this activity. The islands take over and start gain their autonomy and start building a presence in
Right.
space. And
A cla-
they do help. They manufacture and produce items in space that they deliver by reentry gliders to Earth.
Gotcha.
And
Well, let's come back to Earth for a second because I'll get too interested in that in that story. But as you're talking about island colonies, do you think that the population numbers we have currently are sustainable? Because it actually, it's this is in combination with another question I has for you as far as like how important ecological balance is, because we really only have a certain amount of set resources and minerals and renewables, etc. So I'd love to hear your talk on the potential problem of overpopulation and where you think we currently are.
uh, in the mid 70s, 1975 thereabouts, my wife and I were very active in zero population growth movement, and also the anti-Vietnam War thing was going on. So we were young, sort of activists, and so the population projections were really scary. The world population in 1975 was right around 4 billion people. Today it's double that. We're just
Yeah,
past 8 billion. By the turn of the century, it's projected to be between 10 and 11 billion. Now,
crazy.
the population growth rate has consistently declined, especially in Western first world countries. The Pretty much at zero population growth across Northern Europe, the United States, Canada, Japan. Most of the Northern Hemisphere first world states have achieved zero population growth and even less. So Europe population is their native population is shrinking. Typically, the southern hemisphere or the continent of Africa and everything, say third world countries, tend to have a higher reproductive rate. And China, until recently, had a very high growth rate. India
Hmm.
now is going to surpass China in population probably by the turn of the century. So they haven't controlled their growth. But the good news is African countries have really reduced their growth rate, and a lot of that has to do with education of women, availability of birth control. But education seems to be the underlying. The more highly educated you are, the less you want to have 15 kids, I guess.
Yeah, that's the
So,
case. Yeah.
so the argument will go, and Elon Musk is, among other industrialists, have said we're in danger of population collapse. And this is a counterproductive argument because that's absolutely
Hmm.
the wrong idea. He's looking at it strictly from an economic standpoint where he wants a large, cheap labor force to run his businesses. And so
Amen.
that's
Yep.
basically where that's coming from. So the until recently, a lot of scientists had said, well, our agricultural revolution has so improved productivity, we can feed the world, and we are feeding the world. And famines and starvation are largely the result of political issues and wars. But there is enough food, it's a distribution, and that's the issue. That's not. We need to remove a lot of acreage subjected to farming and return it to its natural habitat state. For the health of the planet, for our own survival, we need to do that. And there are technologies where we can grow our food much more efficiently and effectively and with less environmental impact. And in the Netherlands, they have yeah, what's been called factory farming. They're large greenhouses, hydroponically grown produce, tomatoes, lettuce, beans, what you name it, broccoli, and
Hmm.
it's grown hydroponically. It's on conveyors. It's it can be in an urban environment, so your produce, your production is fresh and close to the market. You don't have the large transportation issues. It's essentially no pesticides because it's an enclosed environment and the pests can be
Wow.
kept out. Pretty much organic in that sense. Um, so there are ways of doing that without dedicating thousands and thousands and hundreds of thousands of acres, open acreage to farming, clearing forests and all that stuff that's been done historically. So there is a possibility to do that, and there are plans for future cities that are would have a negative, either zero or negative carbon impact, and those are vertical cities, which would be very densely populated, but the buildings would be terraced, high rises would be terraced. They would have vertical forest. You would grow trees and gardens on these terraces all the way to the sky. You would recycle everything. You would grow mushrooms underground. You would, there's a whole architectural scenario for how this would work. And you would
Right.
bring the rural population into these centers to reduce the impact on natural habitat and reclaim as much of that land as you could for natural habitat, whether it be grasslands or forest lands or whatever it was before it was cleared and developed for farming. So what kind of population could we support? Yeah, in those situations where we had everything developed in that sense, we could support probably this present population. The problem is now the way we are supporting it is, for example, in the Congo, especially in the North Congo, uh, the forests are being cut down for firewood and the encroachments. And of course, we know what's going on in the Amazon,
Right.
especially by Brazil. There, and this new president has vowed to slow down the destruction of the rainforest and so forth. It's going to be very hard for him to do that because there's so much rogue activity going on. They're going and slash and burn and turn it into grazing land. And so in my science fiction novel, I actually we're out 22, 45, 46. The Amazon is a grassland, an arid grassland with a clogged, mud-filled um, small river basin, except for Peru, where they've made a national park out of the headwater area of the Amazon.
Right.
So
But
this is
if we
what
lost the Amazon rainforest, if we lost the Amazon rainforest, wouldn't that kind of be the end of a lot of the ecological balance that we need with trees and the oxygen they provide and the carbon they capture, etc.?
um, it was a huge carbon sink. Let's put it that way. It was always
Hmm.
carbon neutral and oxygen neutral. It consumed as much oxygen as it produced with all the life. So it was pretty much um, oxygen oxygen neutral, but it was a big carbon sink, and it was a habitat for tens of thousands of different species that are going extinct as the forest is removed.
Right.
Uh, the uh, Sahara Desert. There's the winds that blow through there and from the bring dust into the upper atmosphere, which settles over the Amazon, and is part of the fertilization of that whole area. So that's kind of an interesting thing that's going on. But now it was carbon neutral. Now it produces more CO2 than it consumes because of the loss of the forest. So now it is
Hmm.
actually producing more CO2 than than it uses in the plants. The other part on this planet that is threatened is the diatoms, which are small plant-like unicellular animals or plants that live in the ocean, and they're called the pearls of the sea because they have a shell that's made out of silica, and so it's kind of it's flexible, and they're called pearls because they have all kinds of shapes and forms that refract light and produce all these rainbow colors if you get a bunch of them together. They are highly efficient at producing oxygen, and they grow near the surface where they can photosynthesize and they produce oxygen. They're the major oxygen producers of the planet. So it comes from the seas. And the problem we're having with the diatoms and other plankton, they're part of the plankton that the whales eat. The problem we're having is the warming seas. And so they're dying off. They can survive in a certain temperature, but not as the seas warm. They can't reproduce in those seas. So that's a real risk factor. And with our global warming, one of the things that wasn't really accounted for when they were doing their early calculations was the fact that the seas were warming as fast as they have
Right.
been. And water has a peculiar property in that it retains heat. It gives up heat slowly. So once the oceans warm, as they have, it's going to take centuries to cool those off. So that's why I projected a couple hundred years in the future, saying that things are worse. Even if we corrected everything right now, they'll continue to slide in that direction for quite some time.
Right. And have you looked into any sort of the research if humans, or if the seas continue to warm as rapidly as they are now, like we saw even in Europe, there was a crazy spike in record temperatures this winter that climate scientists were aghast by. Now, how long in 100 or 200 years where humans will be migrating all over the place to escape some of this cataclysmic sort of change?
Well, that's the premise of my book. The people who can, so we have a world government, but it doesn't control everything. There are a lot of rogue forces out there and malicious and controlled by crime and syndicates and so forth. But there is theoretically in this novel a world government, and it's based
I'm
in
more
relationships.
and sorry, but I'm more concerned and curious about what you think about like present day nonfiction for humanity, and kind of what things might look like from the research that you've done.
That's a tough one, and like I say, there are opposing forces to progressive ideas and progressive action. So, on the other hand, when we have a catastrophe, we respond well to catastrophe, and climate so far hasn't been seen as a catastrophe. It's a slow-moving effect. Well, it's beginning to show catastrophe now. The Swiss Alps hardly have any snow. Last summer they had a huge heat wave. Right now, well, I don't know what's the temperature in Barcelona. They've had a warm winter.
Up until this month, it's been fairly warm. February so far has been anywhere from between 8 and 12 degrees. So some days warmer than others, but it's cooler for Barcelona. But last summer was unbearable. It was like 70% humidity and 30 degrees at midnight here. It was brutal. So I'm kind of worried about what this summer is going to bring.
Yeah, we don't know how to pack for this trip.
Right. Yeah.
We'll be going April 3rd and about April 16th or 17th, I think we'll be in Bergen, and of course it'll be cooler there, we hope. Well, in California right now, for example, this morning it was probably 1 or 2 degrees, so it was like 30, 35, 35 degrees Fahrenheit.
In California, it's that cold?
Yeah, we're having a cold snap right now. It's colder than historically cold for this time of year. So the disruption of the Arctic airflow and that sort of thing is what's causing these problems. So this wave of air comes down from the Arctic through Alaska, and it's made a refrigerator out of us. And the East Coast is being blasted by storms and snow, and probably getting a lot of stuff that used to come to Europe. So a lot of that stuff is shifted. And so when you look at past weather models and try to project what's going to happen next year or the year after, those models are less and less reliable because Earth hasn't seen what it's seeing right now for a long time. Now, there's another factor in global warming, and that is the sun output, a much slower process, but it is increasing, and it will continue to increase until it expands to a red giant. So that's billions of years down the road, and you and I may not be here then, but so that's another thing that's going to continue to happen that we have to counter on this planet. When you asked before about other habitable planets, there's a difference between a planet that might be habitable now and one that could support evolution as it happened here. So we could find a planet that would be okay to inhabit, but had no advanced life forms. That's possible. That would be ideal, actually. We don't want to be the aliens to come in and take over another culture.
Right. Well, it would fit our species well, but the only thing is who knows who we might encounter. But it seems like from all the signals we've sent out over the past 50 years, we haven't received anything really back that seems like there is intelligent life waiting to greet us with a banana loaf and some bread. It seems like we're on our own here until we develop some sort of warp drive technology a la the Enterprise.
Yeah, right. Well, when you consider that, let's say we've been broadcasting for 100 years, so we have signals out there 100 light years in a radius around our planet, out 100 light years. Now let's look at our galaxy. It's 100,000 light years across. It's 50 light years about 40 light years from our position to the center of the galaxy. So we haven't really covered much ground, even in our own galaxy, even though we've been putting these signals out and supposedly a technological civilization could detect them and then try to figure out what the hell they mean. So I was going to get into another area, but that's it was about an alien civilization picking up some of Hitler's speeches and thinking that that's who we were.
Right. And they're like, well, I think we'll wait a couple millennia until these guys get their things together. Yeah. There's all sorts of things that if the aliens were listening to us, they'd be like, what is wrong with these species? They've had so much time to get their shit together.
That's right.
Yeah, because I think that's why people that are fans of science fiction, as it seems you are, and I definitely am, that the concept of space travel and to be able to explore, I think that's why Star Trek has really stayed the test of time as far as TV and movie, because it really is the positive incarnation of our better angels, going to explore and to like leave civilizations alone and try to help where we can, whereas history tells us that most humans, when they find something new, they're going to probably take it and use it and destroy it, and not to mention what they're going to do to the inhabitants. So it's nice to hear that maybe if we have some space colonies, you and I think would like to hope that these colonies would be the better angels, but I don't know. I think history tells us a different story.
Um, yeah, I addressed that a little bit. Actually, they've done active MRI brain scans on people, and they can determine, for example, the structural difference in the brain between male and female. And there's certain areas of the brain that are structurally different, and account for some of the differences in our worldview. And there is a difference between female and male worldviews. The female is more, um, well, I would say fearful, but careful, more careful. She's charged with raising the species. She has to be protected. She has to be concerned about um, a lot of things to protect the offspring. So the male had to be the hunter, had to be the hunter gatherer, had to support the female, especially with babies and small children to protect. So there are differences in our brains. They have found that there was a pilot study that wasn't followed up on because it was publicly funded, and politically it's probably not something that would gain funding, but it was a pilot study that showed there is a difference in the amygdala in the brains of Republicans and Democrats, or liberal, progressive, and conservative. And the analogy would be, or how that was supported evolutionarily, I believe, because the analogy would be, say you have cavemen and they go out, the men go out on a hunt, and they have their spears and everything, and they're trying to bring down dangerous animals as a food source. And somebody innovates and develops a bow and arrow. So there's a part of the tribe is excited about that, goes with the bow and arrow. They try to go out, and maybe the first go around, the bow isn't strong enough, so they fail. But they have the backup. The men with the spears come in for the kill. But the progressives in the cave decide, well, let's try it a different way. Let's make a stronger bow. Let's make stronger arrows. Let's put a point on them, and so forth. And they go out, and eventually the bow and arrow succeeds because you can kill an animal at a distance. You don't have to get really close with a spear. So the conservatives, the tried and true, is the backup, plan B. And the progressives, you get out there and try something new, and it fails probably a number of times, and you tweak it until it succeeds, and then it's better than the tried and true. So both of these features in our brain, the more conservative viewpoint versus the more progressive viewpoint, were probably evolutionarily selected for. In today's society, we don't have a predator. We don't go out and kill our prey. So that conservative view is based on psychology, based on culture, based on religion, whatever you want to say. It still exists, but it's no longer as effective in our current societies. So you would separate out people who are more highly educated and skilled in their individual areas, and willing to try new things to develop space colonies. You would also have to screen for brain defects. You don't want psychopaths on these colonies. You don't want antisocial people. You're going to be living in a closed environment, close together. You have to
Right.
be socially compatible and so forth. You can come from all over the world. You can be whatever ethnic background. You just have to meet these criteria.
Just don't
So
be a
I
basket
believe,
case.
yeah,
Play
I
well with
believe
others.
that I believe that people could be screened with brain scans and determine whether There was another study, whether they were psychopathic or had tendencies. There was another study out of a university, and again, it was limited, but they did it on psychopaths, and they had a control group, normal population, and they did active brain scans on psychopaths, and they found the connections between the amygdala and the prefrontal lobe to be deficient. There weren't as many connections. So the amygdala is reptilian. The amygdala is the emotional flight or fight, take action right now. The prefrontal and frontal lobes are like, wait a minute, let's analyze this a little bit. That's really not the enemy. That, whatever. We don't need to run. We don't need to fight. We don't need to kill. So it evaluates your initial knee-jerk stimulus, as it were. So they found that psychopaths have a deficient connection from the amygdala to the prefrontal and frontal lobes. And it was a small study, but it indicates that the structure is a major concern, and it also could be a major screening method for people who would occupy space. So you would have you would have the better angels there. That's my idea. You would have the better angels in the colonies. Now, what happens on Earth?
Right. Well, I think I really like the tone of the idea that you think that we would be that reasonable when sending people into space, and that there wouldn't be corporate interest and like these fearful conservatives, like you said, and they're like, well, we don't know what we're going to find on that planet. Bring all your guns, bring all of your fear and your anger, and send in the army to clear the land. But I'm on board with you that I think if we're going to go and explore these other planets, we have to do it with the intention that we have to see what these planets are like, and perhaps we have to inhabit them with with whatever life forms are there. But if we find any that have any idea of threat and defense, I think they'll be against the humans showing up as a roommate on their planets.
Yeah, and here's another idea. Suppose there is life of whatever form on another planet that we attempt to at least partially occupy or have a base on or whatever. There's been a lot of science fiction written about germs from space and viruses and all this stuff that we don't have antidotes to. And if it's an independent genesis, the likelihood that it would be identical to our own physiology, our own biochemistry, is extremely improbable. So we wouldn't have the enzymes to eat any plant food or any of the life on that planet if it was a separate genesis. Likewise, if they had infectious agents, they would not have access to our own biology. Highly unlikely that they would. So we would be, in essence, if we did occupy a planet that had other life on it, and in some ways we wouldn't be competing with that other life form. In other ways we would. For example, we'd be competing for energy, but as far as our biology, right, we probably wouldn't be competing with them. But who knows? That's the big number one question in biology today. The only assumption we can make about alien life that I believe viable is, number one, it's carbon-based and needs water, liquid water. And number two, it has to have complex molecules. But they don't have to function in the same way. They have to have a means of transporting electrons and harvesting energy, because life is counter to the universe. It goes from simplicity to complexity, and in the process burns energy. The universe goes the other way. So it goes from complexity to simplicity. That's, what is that called? Entropy. Order to disorder. Right. So
That's all so fascinating to me, and as we start to wrap up, I want to be respectful of your time. I wonder for a final question if we're going to make it to the point of creating these space colonies and keeping the planet habitable until then and in perpetuity, what sort of hopes do you have for humanity over the next couple hundred years? Like, what would you really like to see us do as a species to save our own home?
yeah, there's an idea that I had, how probable it is, I don't know, but suppose you have developed a lot of space colonies, they have assets in the asteroid belt where they can harvest asteroids, they can make products, they can transport them into the interplanet area near Earth. They can use gliders and so forth, re-enter gliders to deliver all of this stuff to the planet so that Earth doesn't have to um, you can stop logging, you can stop essentially slow it down a lot. You can stop toxic practices like mining because that
Mm,
those materials could be delivered to you from the asteroid belt. If you urbanized the population, in other words, built these cities that were, say, carbon neutral and had parks and trees all over the place to keep the environment there healthy and human healthy, and then the wildlands, let's say, the natural habitats, you would have caretakers of these areas. So much like park rangers and stuff like that, they would provide access routes and access to for the population to go in, like on vacation, for example, to go into these areas,
mm,
hiking, camping, and whatever, and it could have very low impact on the environment. Um, so you would have a large population that would be dedicated to caretaking of the natural habitats, and you would have game preserves that would be in a natural habitat, a lot of like what you're doing and what is being done in Africa to support the elephants and the lions and so forth that are being poached, and so you could have a large number of people dedicated to as caretakers of the planet. Let's put it that way, caretakers of the planet, and you could develop your food sources. Much of it could be developed sequestered from the natural environment, so it doesn't have an impact. So you don't use pesticides, you don't use chemical fertilizers and things that were herbicides and so forth that kill the soil and a lot of species and the pollinator collapses that we're seeing that affect everything. So I see that it's possible to do this. They have plans. In New York somewhere. There's a plan for this building that is a skyscraper, but it's terraced, and
mm.
it's a whole community that I forget how many people would live there. So you can mimic some of the ideas that you would use in space colonies to develop urban centers in on Earth. What kind of population that would support? It may support as much as we have, but they
Hmm.
would not have it would there would not be the severe impact on our environment. It's the encroachment into wild areas that is so damaging, and it's the overproduction of carbon dioxide and methane. So in these ecosystems in space, there's a lot of attention that would have to be given to balancing animal versus plant life because animals produce CO2, plants consume CO2. And so they have to be in balance. And so population on these colonies would have to be strictly controlled, and the number would have to be determined by a conglomerate of different scientists, physicians, and so forth to determine what the environment, how many people and how many animals the environment could support. And if you have a growing population, you're going to have to build more colonies. And if you want the analogy on Earth in ancient times, pre-Columbian times in the South Pacific, Pacific Islands, the cultures there, they when the population reached a unsustainable level or was threatening to reach an unsustainable level on any given island, the young people got in their canoes and went off in search for another island so that they could maintain the population on that island that was sustainable. The same analogy would apply to space islands, but I think they would be an assist both in developing technology for Earth, you can grow with bioengineering. You can grow bacteria in tanks and produce whatever you want. You can produce different proteins that would be then assimilated to make fake steaks or fish sticks or just be a protein source with a patty and whatever. That technology is here today. There's a new bacterial derived technology. In other words, it was discovered in bacteria, so it's a very ancient process. It's called CRISPR. Have you heard of CRISPR?
I have. Mm-hmm.
So it's been used. It can be used in food production. It can be used in all kinds of things. So it was used to cure a homozygous a patient, a boy, who had sickle cell anemia. He didn't have the trait. He was homozygous, so he was going to live, late teens at the best. So they took some of his bone marrow, which produces the red blood cells, and they put it through this CRISPR technology. And since sickle cell anemia is a point mutation, which means it's one nucleotide substitution that causes the problem, they could scissor that out and they could insert the correct one, grow it up in a petri dish, re-inject it in his bone marrow. And so now he's symptomatically, he's like a heterozygous. So he still produces sickle cells, but many fewer. And he does produce normal cells. So he doesn't have this severe crisis anymore.
Wow.
As far as I know, that's the only medical application of CRISPR. And it was simple because it was a point mutation. Most of them are much more complex than that. So
Right. Yeah, I think they're going to be using it for some crop production as well, and there's still some ongoing trials that they're having to see where it can be helpful and where it can't be. There's obviously a whole bunch of people that are scared for how it might be used to create like designer humans and to change the the evolution of our genome. But I think that's for another conversation. But I appreciate you sharing all of your research and ideas with me. I think we all hope that we'll get to the space colony part, because that means that we would have, hopefully, been better custodians of our planet for the next 200 years, and maybe we can reduce and reverse some of the ecological collapse that we seem to be heading towards. So it's always nice to speak with someone who is more optimistic and wants to see a better world.
have the great solution.
Right. Yeah. Yeah. So I'll be looking out for your next book as well. And what was the title of the coming novel? Islands in the Mist.
No, Islands in the Void. So
In the Void.
Islands in the Void. So I kind of took the analogy of the South Pacific Islands into space, and that's why I named it Islands in the Void. And actually, I call them. They developed each as a cluster around a manufacturing facility that is in space and supports them. I call them archipelagos because they are islands. So
right, that's great. It's a great concept. I'll be looking out for it.
Okay.
And yeah, thanks very much for your time, Richard. I appreciate it.
Thank you.
So thanks for listening to No More, No Less. I appreciate the time you spent with me today. So please subscribe and rate the show if you enjoyed it. It'll help me create more amazing content and get that next little bit of validation that I so deeply crave. If you did enjoy it, well, that sucks. But to make sure, I think you should listen to my next 10 episodes and then decide. I mean, come on. Rome was not built in a day. I'm just getting warmed up here, guys. So thanks again. See you next time.